It is 10:41 in the morning, 66 million years ago, somewhere over what will one day be called the Yucatán Peninsula. You have exactly 90 seconds left to live, and you don't even know it yet. A herd of Alamosaurus grazes peacefully in the distance, massive shapes moving like living hills against a golden sky. Birds that are not quite birds yet wheel overhead, and the air smells of crushed fern and warm earth. Then the horizon ignites. A second sun rises in the south, silent and blinding, and every instinct in your body screams that something has gone catastrophically wrong. This is the moment a mountain-sized rock slams into Earth at 45,000 miles per hour, and in the minutes that follow, you will learn exactly how fragile life on this planet has always been. But this single afternoon is only one entry in a much longer, much darker catalog. Because if you think that asteroid was the worst thing this planet has ever thrown at a living creature, you have no idea what Earth is truly capable of. For most of its 4.5 billion year history, this planet was not a cradle for life. It was a furnace, a poison factory, an ice tomb, and a pressure chamber, sometimes all within the same 100 million years. Scientists who study deep time often say that if you compressed Earth's entire history into a single calendar year, humans would not appear until the final seconds of December 31st, and everything resembling a stable, breathable, temperate world we'd recognize would occupy only the last few minutes of that year. Today, we are going to strap you into a suit of modern engineering and drop you into 9 of the deadliest moments this world has ever produced. From the instant it was born to the depths of the last ice age. Some of these deaths will take milliseconds. Others will stretch out for agonizing hours. All of them will remind you that the comfortable blue sky above you right now is an extraordinary and temporary gift, built on the wreckage of catastrophes almost too vast to comprehend. Check your seals. Check your oxygen readout one more time. We begin at the very beginning. Rewind the clock 4.5 billion years to the Hadean Eon, a name borrowed from the underworld for good reason. The instant you materialize here, your inner ear tells you that you're falling because there is no solid ground to stand on. The entire surface of the newborn Earth is a churning ocean of molten rock stretching to every horizon, glowing dull red where it has begun to cool and blinding white-orange where fresh material wells up from below. The entire planet is less a world and more a wound that has not yet scarred over. Surface temperatures exceed 2,000 degrees Celsius, hot enough to boil the throat of an active volcano, hot enough to vaporize steel in seconds. Your suit's cooling systems max out within a fraction of a second, fighting a losing battle against heat that can melt composite armor designed to survive atmospheric re-entry. Above you, there is no blue sky, only a thick, choking blanket of orange gas, roiling with lightning that flashes without sound, because the atmosphere is too dense to let thunder travel cleanly. The atmosphere presses down with 100 times the force of modern Earth's air, the equivalent of being dropped nearly a mile underwater with zero warning, zero decompression, and zero chance to adjust. And looming directly overhead is something almost incomprehensible. The moon, 15 times closer than it is today, filling half the sky, a cracked and volcanic sphere racing across the heavens, because a full Earth day at this point lasts only 4 hours. The two worlds are so close that they are, in a very real sense, still tearing at each other, still settling into the relationship that will define both of them for billions of years. That proximity does more than look terrifying. Its gravity pulls tidal bulges out of the magma ocean that scientists estimate towered miles high, liquid rock waves crashing across a planet that had barely finished forming, waves that would make even the worst tsunami in recorded human history look like a ripple in a bathtub. One of these fiery walls collapses on top of you before you can even process what you're seeing. Between the crushing atmospheric pressure and the instant vaporization from the heat, you last roughly 0.05 seconds. It is, in a strange way, the most merciful death on this entire list because your nervous system never gets the chance to register pain. Your brain does not even have time to send the signal. Fast forward 2 billion years, and the danger flips entirely. Welcome to the Great Oxidation Event, roughly 2.4 billion years ago, one of the first mass extinctions in Earth's history and arguably the most consequential one this planet has ever experienced, because without it, none of what comes later would be possible. Newly evolved cyanobacteria have discovered how to perform photosynthesis, pumping oxygen into the atmosphere for the first time in the planet's history. To us, oxygen is life. To nearly every organism alive at that moment, an anaerobic world built entirely on chemistry that has never once had to deal with this reactive, corrosive gas. It is lethal poison, and billions of ancient microbes are dying in real time as this new gas floods their world, choking out entire ecosystems that had thrived for 1 billion years in an oxygen-free ocean. But the oxygen does something else too. It reacts with and destroys atmospheric methane, the greenhouse gas that had been keeping the young Earth warm despite a fainter, younger sun. Without that insulating blanket, the entire planet plunges into what geologists call the Huronian glaciation, one of the longest ice ages the planet has ever endured, and you find yourself standing on an endless ice sheet at negative 70 degrees Celsius, a temperature colder than anywhere ever recorded on modern Earth, colder than the coldest days at the South Pole. Snow-white ice reflects 90% of sunlight back into your eyes. Without protective filtering, you would go blind within a minute, the glare more intense than staring directly at a welder's torch. Worse, this light carries a hidden threat, because Earth still has no ozone layer at this point in history. Unfiltered ultraviolet radiation bombards the surface directly, and even through a sealed visor, you feel a tingling burn on exposed skin. Your suit's batteries, drained by the fight against the cold, begin failing one system at a time. Ice works its way past compromised seals, first as a fine dust, then as a creeping film that refuses to melt. Spacesuits are built to handle the vacuum of space, which is actually an excellent insulator because there is no medium to carry heat away from your body. But down here, in a thin atmosphere with wind, convection strips heat from you hundreds of times faster than a vacuum ever could, turning your suit's own design against you. You survive roughly 3 hours in this frozen graveyard before hypothermia claims you, your thoughts slowing, your vision narrowing to a tunnel, and your body will lie perfectly preserved by the ice for millions of years afterward. A strange, out-of-place fossil waiting for nobody. Push forward again, roughly 1 billion more years, to the Cryogenian period around 700 million years ago, an era geologists now refer to, quite literally, as Snowball Earth. This time, you land on what should be the equator, a place that ought to be humid and green, thick with tropical life, but instead you find total silence. Oceans are frozen solid all the way to the bottom in some regions, locking entire marine ecosystems into a shell of ice that, in places, may have been over a kilometer thick. There is no wind, no movement, nothing resembling weather at all. The landscape looks less like Earth and more like Europa, Jupiter's ice-locked moon, a comparison that planetary scientists actually use when trying to understand what conditions on Snowball Earth may have been like, since the two worlds share an eerie frozen kinship separated by hundreds of millions of miles. Curiosity might tempt you to crack open your visor and breathe the still air, but that decision would be fatal within seconds. Nearly all of the atmosphere's oxygen has been consumed, oxidizing exposed rock over millions of years, leaving the air essentially sterile, a thin shell of gas with almost nothing left to sustain a breathing creature. You'd inhale deeply and feel nothing but emptiness filling your lungs, a genuinely disorienting sensation of breathing without receiving, unconsciousness arriving in about 30 seconds, an almost peaceful death compared to what came before. If you kept your visor sealed instead, you might last around 10 minutes before the deep cold eventually finishes the job, regardless. Deep beneath that endless ice, though, volcanoes are already pumping carbon dioxide skyward, slowly, patiently, over millions of years, quietly building toward the thaw that will one day allow complex multicellular life to explode across the planet in what scientists later call the Cambrian explosion, one of the most important bursts of evolutionary innovation this planet has ever seen. Jump ahead again to the Carboniferous Period, an age of forests so vast and dense they would eventually compress into the coal seams that quite literally power much of the modern world, buried, crushed, and transformed over hundreds of millions of years. Here, finally, you can remove your helmet and breathe freely, and the air feels almost intoxicating because it is. Atmospheric oxygen concentration sits around 35%, compared to 21% today, and that extra oxygen floods your bloodstream with a euphoric, stimulant-like rush. It feels like you could sprint a marathon without losing your breath, like your muscles have been handed an unlimited supply of fuel. But that sensation is deceptive. Excess oxygen accelerates cellular damage even as it energizes you, quietly oxidizing tissue faster than your body can repair it. And the oxygen has done something else, something far more visible and far more alarming. It has allowed arthropods, creatures whose respiratory systems depend on oxygen, diffusing directly through their exoskeletons, to grow to genuinely monstrous proportions. A dragonfly-like insect called Meganeura buzzes past with a wingspan close to 28 inches, moving with the low hum of a small helicopter, casting a shadow larger than a hawk's. In the undergrowth, an 8-foot-long millipede called arthropods, the largest land invertebrate ever to exist, rears up to eye level, its segmented body clicking softly as it moves. Insects, not dinosaurs, rule this world. Dinosaurs have not even evolved yet, and some of these arthropods grow 10 times larger than their modern descendants, thanks to the oxygen-rich air fueling their growth. The real killer here, though, is physics itself. Thunderstorms in an oxygen-saturated atmosphere become genuinely explosive, and when lightning strikes dry timber, even damp wood ignites almost instantly. Fire tearing through the forest at shocking, almost unnatural speed, far faster than any wildfire in the modern world. You try to run, but the ground beneath you is not solid, It's the endless swampland that gives the Carboniferous its name and its coal, and you sink to your knees in mud as a wall of flame roars toward you like a jet engine, consuming everything in its path with a heat that outpaces your ability to escape. You last about 4 hours before the fire catches you, one of the more brutal deaths in this entire timeline. Now travel to 232 million years ago, to an event with one of the strangest names in Earth's history, the Carnian Pluvial episode, remembered today by geologists as the longest sustained rainfall the planet has ever experienced. You materialize on the vast supercontinent of Pangaea, and rain is already falling in sheets, visibility reduced to a gray blur stretching toward distant mountains you can barely make out. This isn't a passing storm, and it isn't even a season. This deluge began roughly 100,000 years earlier and will continue in pulses and cycles for another 2 million years. Its cause lies on the opposite side of the globe, where colossal volcanic eruptions in what will one day become Alaska and Canada, part of a vast igneous province, are hurling enormous quantities of carbon dioxide into the sky, turning the entire planet into a greenhouse almost overnight in geological terms. Oceans evaporate at accelerated rates, entire seas losing measurable depth over centuries, and all that moisture comes crashing back down onto Pangaea in an endless global steam bath that never seems to break. The rain itself isn't what kills you, though, however relentless it feels, soaking through every layer of your suit. It's the air. Temperatures hover around 40 degrees Celsius with 100% humidity, conditions where sweat simply cannot evaporate, meaning your body loses its only real cooling mechanism entirely. You begin, quite literally, cooking from the inside, your core temperature climbing steadily with nowhere for the heat to escape. Through the sheeting rain, a small, quick shape darts into view. Eoraptor, one of the earliest known dinosaurs, barely larger than a modern dog, watching you with what might be patient curiosity as your body temperature climbs toward failure. Your heart gives out after roughly 12 hours and you collapse into warm mud, joining countless other creatures that this same rain has already claimed. This soggy, miserable, seemingly endless era, though, becomes the launch pad for something extraordinary. The mass extinction it triggers among Pangaea's dominant reptiles clears ecological space, and it sets the stage for the rise of the dinosaurs, who will go on to dominate the planet for the next 160 million years, a reign longer than almost anything that comes after it. That brings us back to where this journey began, 66 million years ago, on that sunlit Texas plain surrounded by grazing titans. The vibration you feel isn't thunder, and it isn't a predator, though a Tyrannosaurus rex does happen to be nearby, producing not the movie roar you'd expect, but a deep, bone-rattling infrasonic rumble, according to current scientific reconstructions. A sound you feel in your chest before you hear it in your ears. None of that matters anymore, because on the horizon, a second sun has already ignited. A mountain-sized asteroid roughly 6 miles across has struck the shallow sea 1,000 miles away, in the region that will become the Gulf of Mexico, instantly vaporizing cubic miles of rock and water and punching a crater nearly 90 miles wide into the Earth's crust. The shockwave itself won't reach you for another 50 minutes, plenty of time for the sky to change color twice over, but something faster arrives first. The seismic wave, carrying the force of roughly 100 million megatons of TNT, more explosive energy than every nuclear weapon on Earth, detonated simultaneously and multiplied many times over, rips through the ground beneath your feet and throws you into the air like a discarded toy. Alamosaurus giants collapse around you, bones snapping as the Earth itself convulses beneath their enormous weight. Trees are torn from the soil like corks pulled from bottles, entire groves flattened in an instant. Overhead, the sky begins glowing an ominous red as vaporized debris, ejected far beyond the atmosphere, starts re-entering at hypersonic speeds, heating the air into something resembling an oven. A phenomenon some researchers believe may have ignited wildfires across much of the planet within hours. You never live long enough to feel that part. You survive roughly 5 minutes, the time it takes for the seismic wave to arrive and finish what the impact started. In the aftermath, dust and sulfate aerosols choke out sunlight for years, plunging the planet into what amounts to a nuclear winter, and the cold, dark, hungry world that follows kills far more organisms than the initial blast ever could. Roughly 3/4 of all species on Earth vanish in the extinction event that follows, including every non-avian dinosaur, clearing the stage for a very different, much smaller kind of animal to eventually take over. Skip ahead an almost unimaginable span of time to 125,000 years ago, the Eemian interglacial period, and for the first time in this entire journey, the world actually looks familiar. You find yourself in a lush, humid forest thick with the scent of fruit and flowers, temperatures sitting at a comfortable 25 degrees Celsius, birdsong drifting through the canopy. You're standing on the bank of a wide river that will one day be called the Thames, roughly where Trafalgar Square will eventually stand, Except right now there are lions and hyenas prowling the area instead of pigeons and tourists, and the streets you might picture are still tens of thousands of years from being paved. Sea levels during the Eemian sat around 20 feet higher than today because the world was running slightly warmer than the modern climate, and Britain has been cut off from mainland Europe by rising water, making you, as far as the fossil and archaeological record suggests, the only human being on the entire island. A straight-tusked elephant emerges from the tree line, standing roughly 10 feet taller than any modern elephant, an impressive but largely peaceful giant that regards you with mild disinterest before returning to strip leaves from a low branch. The real danger is waiting in the water. Overheated from the humidity, you approach the river to cool off, and the surface explodes as a hippopotamus weighing close to 1.5 tons charges out at you with startling speed for something so massive. Hippos ranged across nearly all of Europe during this warm interval, since mild winters kept rivers from freezing solid, and they remain, even in the modern world, among the most aggressive large animals on the planet, capable of short bursts up to 19 miles per hour on land despite their bulk. In dense riverside grass, tangled and slick from recent rain, you stand no chance of outrunning it. You last about 30 minutes before becoming, in the coldest scientific terms, a predation statistic in what should have been paradise. The next stop takes you to roughly 74,000 years ago, to one of the closest calls our own species has ever faced. A moment some anthropologists describe as the narrowest bottleneck in the entire human story. It's midday, but the sun has been reduced to a dim smudge behind a filthy gray haze that stretches from horizon to horizon. Ash, not snow, drifts down from the sky, settling on your shoulders and gathering in the folds of your suit. On the far side of the world, the Toba supervolcano in Indonesia has just produced the most powerful eruption of the last 25 million years, an event so large it left a caldera nearly 100 kilometers long, hurling enormous volumes of sulfur and dust into the stratosphere and plunging the entire planet into a volcanic winter that some researchers estimate lasted the better part of a decade. Photosynthesis stalls under the dimmed sunlight, plants die back across whole continents, and animal populations collapse in a cascading famine that spares almost nothing. Geneticists studying human DNA have found evidence of a severe population bottleneck around this time, with some estimates suggesting our entire species may have shrunk to only a few thousand individuals scattered across Africa and beyond, a number small enough that a single bad winter, a single failed hunt, could have ended the human story entirely before it truly began. Shivering through the snow and ash-dusted forest, you spot the carcass of a deer, salvation at last. But someone else has already claimed it. These are people, but not quite like you. Shorter, broader, with barrel chests and heavy brow ridges, built low and dense against the cold. Neanderthals, physiologically built for exactly this kind of brutal environment, with denser muscle mass and superior heat retention, honed over hundreds of thousands of years in Ice Age Europe. To them, you're not kin, you're competition, one more mouth threatening a scarce and hard-won kill. The one who spots you rises with a stone-tipped spear, calm and unhurried, and your stiff, cold-numbed body has no chance to flee across the frozen ground. You survive roughly 40 minutes, a stark reminder that Homo sapiens very nearly lost this particular chapter of history to a more cold-adapted, physically superior cousin. The final stop is the last glacial maximum, deep within the most recent ice age, somewhere around 20,000 years ago on the ground that will one day support the Eiffel Tower. Northern Europe lies buried beneath an ice sheet 1.5 miles thick, an almost incomprehensible weight of frozen water pressing down on the continent, and the air temperature sits at a brutal negative 50 degrees Celsius. Modern synthetic clothing would freeze solid within 5 minutes out here, becoming brittle and useless almost instantly. Yet, in the distance, people are walking calmly across the frozen steppe as though this were an ordinary afternoon, their breath forming brief clouds that vanish almost as quickly as they appear. These are Cro-Magnon humans, and their survival secret isn't biology, it's technology, a set of inventions that quietly changed the trajectory of the entire species. The invention of the eyed bone needle allowed them to stitch multi-layered, wind-blocking garments from reindeer and Arctic foxhide, effectively engineering the first true winter survival suits thousands of years before anyone imagined space travel. They build shelters from mammoth bone frames covered in hide, dozens of massive bones interlocked with remarkable precision, heated not by scarce wood, which barely exists on this treeless steppe, but by burning animal fat in shallow hearths. A coordinated group in the distance is driving a woolly mammoth using nothing but teamwork, language, and spears tipped with carefully worked stone, making them, pound for pound, the deadliest and most organized hunters this frozen world has ever produced. You attempt to reach them for help, moving as quickly as the biting wind allows, but a sudden blizzard drops, visibility to zero within moments, swallowing the horizon whole. Without their skills, their fire, or their generations of accumulated knowledge, the cold takes you within about 30 minutes, just a couple hundred feet from the warmth of their settlement, close enough that if the wind had shifted, someone might have heard you. 9 deaths across 4.5 billion years, vaporized in magma before your nerves could register the pain, frozen solid in the planet's first great extinction, suffocated in the silence of a global snowball, incinerated in an oxygen-fueled inferno racing across an ancient swamp, boiled alive over the course of a single unbearable night during 2 million years of relentless rain, crushed by the seismic force of an asteroid's impact before the fires ever reached you, hunted by a river giant in what should have been a warm and gentle paradise, speared by a Neanderthal during humanity's darkest and most precarious winter, and finally lost to a sudden blizzard just steps from salvation and warmth. Every single one of these eras actually happened, backed by ice cores drilled from ancient glaciers, fossil records pulled from layered rock, and geochemical evidence preserved in sediment laid down millions or billions of years ago and only recently decoded by modern science. And yet, here you are, breathing easily, reading this in a climate-controlled room on a planet that spent almost all of its history actively trying to kill everything living on it. The comfortable window we call human civilization, with stable coastlines, reliable seasons, and breathable temperate air, represents an almost impossibly small sliver of Earth's total timeline. A sliver so thin that if you blinked at the wrong moment on the geological clock, you would miss it entirely. If the planet's entire 4.5 billion year history were compressed into a single 24-hour day, the truly hospitable conditions we take for granted, the ones that allowed agriculture, cities, language, and everything else we consider ordinary, would occupy only the last few seconds before midnight. Everything before that was heat, poison, ice, pressure, fire, or some brutal combination of all 5 at once. So the next time you step outside and feel nothing more dangerous than a light breeze, remember that you are living inside an extraordinary and fragile exception, one that took 4.5 billion years of catastrophe, extinction, near annihilation, and quiet reinvention to produce, and one that is, by every measure geology can offer, far more temporary than any of us would ever like to admit.